Great. I think I'll make a start. Well, hello and welcome everyone to this EIA Community Debate, Designing Infrastructure for Climate Resilience and Extreme Weather. This event has been organised as part of our work for the EIA community, which provides a forum for thought-provoking critical conversations around EIA from a science perspective. The community aims to connect and support environmental scientists and practitioners working across a range of specialisms involved in the EIA process, and to facilitate meaningful discussion between disciplines on the key issues facing the sector. The community champions the ethos of utilising EIA as a tool to support decision-making, which leads to better environmental impact and developments, and is focused on providing environmental professionals involved in EIAs with the knowledge and skills to support this. Shortly, I will post a link about the community in the chat so that you can find out a little bit of more information, including how to join. But in the meantime, please do introduce yourselves in the chat and share where you're joining from today. This event is actually going to build on discussions from our previous EIA community debate on extreme weather and EIA, and will be focused on the need for climate and weather-related impacts to be better explored during planning and development to ensure infrastructure is fit for the future. So this is the agenda for today. As you can see, the event is going to be split into two key parts. The first will provide an overview of Network Rail's approach to assessing the impact of climate change and weather events on their infrastructure, and how findings from these have fed into assessments into design, construction and maintenance projects to ensure resilience. And that will be presented by Lisa Constable, who I introduce shortly. And the second will be a workshop focused on climate resilience through design, the year 21-24, which will be facilitated by Eleni. Again, I'll introduce her just before we get to that part of the session. As you'll see, this is set up as a meeting today, so I did want to go over some quick housekeeping quickly. As we are keen to facilitate as much discussion as possible, we've made this a meeting as opposed to a webinar. So during the discussion, please do turn on your cameras and get involved. We're really keen to hear from you. During presentations, however, if you could just keep muted and turn off your cameras to limit distractions. And then when we come back for questions, turn them back on so that we can all get involved. In terms of questions, there will be a short amount of time for them after some of the presentations. You can either raise your hand using the raise your hand function through Zoom, or you can just post a question in the chat and I'll then ask these on your behalf later on. Just to flag that the meeting is being recorded, but only the presentations will be shared. The rest of the recording is just for our kind of note-making purposes, and we will share a summary of discussions after the event. Great, so I'll just stop sharing my screen. Great to see so many of you here today, and I'm really pleased to introduce the first part of the event today, and our first speaker. So we'll kick off the first session with Lisa Constable. Lisa is Strategic Lead for Weather Resilience and Climate Change Adaptation at Network Rail. She is working to implement Network Rail's climate change strategy and to embed management of climate risk within policies and procedures and support the regions with implementation of their adaptation plans. A massive thank you to you, Lisa, for taking part today, and I'll hand over to you for your presentation. Thank you.
That's great. Thank you very much, and thank you for having me. It's great to be with you all today. Let me just get my slides up. Have those come through?
Yes, thanks. If you just go, perfect.
Perfect. So yeah, it's great to be with you all today. As Ethany said, I am Strategic Lead on Weather and Climate Change, so covering the whole of Great Britain, providing guidance and support and tools to our regions. So I'm just going to give you an overview of the kind of high-level stuff that we do and an example of adaptation in action. But just to start with, pretty much any kind of weather that there is in the UK impacts the railway in one way or another. Storms impacting coastal assets with coastal erosion, sea level rise, spray from waves, can wash away the assets or damage trains running close to the sea. There's a lot of washouts of embankments and track and scour of bridges when it comes to flowing water from rivers or floodwaters. Wind and storms brings anything you like onto the track. So here we've got leaves and trees and sheds, but we get trampolines, we get balloons, we get all sorts of things. So there's a lot that we have to deal with. And there are a lot of people working in the railway in terms of how we go about doing this. Just to show you some of our data. So you know, I know EIAs are looking kind of more into the future for projects that haven't been built yet, but to give an indication of what happens when the railway is trying to run in bad weather, this shows how weather has impacted performance over the last 18 years. So the PPM is the public performance measure, and this is basically a record of the number of trains that reach their final destination within 5 or 10 minutes of their scheduled time. And we can see that when we have extreme weather, and this is, you know, when the Met Office issues a warning, for example, we can have a very significant drop in performance. This is an annual average. And so where you see in 2010 and 2018, you know, up to a kind of 20–25% drop in performance as a result of weather, that's very significant. Now, these two drops were snow, so the Beast from the East in 2018, and then we had very widespread snow in 2010 as well. And that just kind of freezes the whole network. But in general, there's a drop in performance on extreme weather days. An adverse weather day is a day when the railway turns 200 next year, and when our assets struggle to perform in weather conditions that, you know, you or I as the traveling public would be like, it's raining, it always rains in the UK, why are the trains not running? Or it's just a little bit warm. You know, and we can see that there's also that kind of 4% drop in performance on those adverse weather days. And this just shows how our assets struggle with existing weather conditions, let alone future weather conditions. Breaking this down into more detail, so this shows the costs of delays and cancellations. So, you know, every delay that occurs on the railway is attributed to a cause, and these are the ones relating to weather, again, over the last 18 years. And what I find, you know, I'm not going to go into detail of how much things cost, except to mention that in around about 2015, the cost of a delay minute went up. So some of this increase in cost is as a result of an increase in the cost of a delay minute. But the interesting thing about this chart is how last decade, we used to have kind of wet and windy, so the green and dark blue, or we used to have cold and snowy, white and light blue. And, you know, that's kind of how the weather was. And again, here, wet and windy. But when you get into the more recent years, so over the last kind of 5–10 years, these bars get a lot more colorful, particularly the red, which is, you know, our really hot summers. We have, what we're finding is we have a hot summer, which dries out the earth, and then we get a wet autumn, which then causes landslides and earthwork failures. And so we're getting a much wider range of weather impacts than we have done in the past. And this is because of a change in the, you know, a change in the weather that we're experiencing. And looking, and, you know, I'm sure this community is very familiar with climate change, but this is my favorite chart for explaining what we do, so I'm going to include it anyway. You know, the railway was built largely 150 odd years ago to operate within a known climate. And so it was built within a critical threshold where a known type of event would be exceeded, and that was considered to be an acceptable level of risk. The thing with climate change is that these extremes are becoming business as usual. And so that what was an acceptable level of risk is now becoming unacceptable because of the increase in frequency and intensity of these events that are exceeding our coping threshold. And in the future, we're going to be seeing even higher extremes. And so the only way for us to manage these is to adapt to increase that coping threshold. And you know, identify what these challenges are and build that resilience into the system. And the opportunity of going through the EIA process prior to project development and design, that is where we need to identify where our resilience and adaptation options are to build it in before we even start to develop the project. So that is really, really important. So what are we doing in order to adapt to a changing climate? We have So climate change adaptation is one of the key pillars within the environment and sustainability strategy. And all of the work that we're doing is aligned with what's in that. And just some of the key activities we have are, over the next 5 years, we're going to be developing long-term 100-year climate change adaptation strategies using the adaptation pathways methodology. So, we will start to be looking at where we may need to make transformational change along the network. And then hopefully, the plan is for these long-term plans to then start to be built in kind of step by step into our 5-yearly business planning process. And within that business planning process, so CP7 is our next control period. It starts on Monday. So CP7 runs from April 2024 until March 2029. And we're just finalizing our regional weather and climate change investment plans for that 5-year period. And that sets out the vulnerability of the railway within a particular region and the action that is being taken in CP7 to manage that risk. They're going to be published on the adaptation pages of the Network Rail website on hopefully the 17th of April, if you want to have a look at that in detail. We're also doing a lot of work in relation to climate risk assessment and adaptation planning. And I've got a slide just now talking about the risk assessment, but it's aligned with ARP3, so our adaptation reports through to DEFRA. And by reviewing the risk, we can then identify what actions we need to take forward. So that kind of underpins everything we do. We use that risk assessment to help us manage risk through updating policy standards and processes, building change into the asset designed within our standards, having it in the kind of capital delivery project development process, for example. And supporting all of this, then we do research analysis, preparation of guidance and tools to support all of this work, and a lot of collaboration with the rail sector and other infrastructure managers to, share experience and lessons, and collaborating on projects that can help all of us address this massive and very expensive challenge. So I mentioned climate risk. So under the adaptation reporting power in the Climate Change Act, we've produced 3 reports. The most recent was in December 2021, and we're currently preparing our 4th, which will be issued by December this year. And this has got a very detailed risk assessment. We've taken all of our different asset functions. So there's about 15 different asset functions, and then kind of sub layers to those assets. So, drainage, earthwork structures, structures has got your bridges, viaducts, culverts as the sub assets. So all of those asset types, we then applied those to all of the different weather impacts, so the climate hazards. And then we did a detailed risk assessment of how, what is the risk to the railway now? And then what is the risk in 2050 and 2080? Just to say that the rail sector has made a decision that we will be using RCP 6 and RCP 8.5 in terms of the climate change projections for all of our work going forward. So generally, design and optioneering needs to be based on RCP 6 with a stress test against RCP 8.5. This is so that we don't gold plate our assets. I can come up to that. I can talk about that later. But anyway, in the risk assessment, so we've done this assessment and we have scored our risks. So this is only those scoring moderate, major, and severe. But what you can see is there's a significant shift from current to 2050 to 2080 in the number of major and severe risks if we don't take any action. And the severe ones primarily sit within the geotechnics function. So this is your earthworks, cuttings, and embankments. There's also, when it comes to precipitation and sea level rise, you're looking at drainage and coastal infrastructure that is going to be impacted. Temperature is looking largely at track infrastructure, and then your storms and wind at overhead line equipment. All of the detail of this is in our adaptation report, which is on our website. We've also done a piece of work looking at interdependencies. This chart is in the report. Don't expect you to read it on here. And this is the first piece of work we've actually working with Transport for London, National Highways HS2 on a kind of a more detailed project in London, trying to actually score the risks between these different the interdependencies between other infrastructure operators and Network Rail, so that we can understand the risks better and then start working with each other to manage some of them. So there's a lot of information in terms of what the risks are to the railway from climate change and how we expect these to change into the future, that could support the development of EIAs as a starting point. We also have 2 guidance notes, and these are linked to our Environment and Social Minimum Requirements Standard, which is for design and construction, known as 015. And this requires that projects going through the PACE process, can never remember what that stands for, I'm sorry, but it's Network Rail's project development process. And it's projects that go through that process need to undertake a climate risk assessment and to use the findings from that process in the design of the project that they are developing. So the 2 guidance notes that we have, one is how to undertake a weather and climate change impact assessment, and the other one is climate change projections. And so I mentioned the RCPs that we use, and the guidance note is directly linked to which RCPs we want to be using, and it provides a summary of the data drawn out of the UK climate projections and put in a format that is easier for engineers and designers to use, since we're not all scientists and it can be hard to get the data out of the Met Office site sometimes. There is also other information to support these assessments, and that is ARP3, I mentioned, the detailed climate risk assessments, the regional weather and climate plans. So we've got them for 2014 to 19 and 19 to 24 on our website at the moment. And I mentioned the CP7 plans for 2024 to 2029 are being published next month. And so that provides some useful information in terms of what's being done in certain areas. And then we also have a Power BI tool which pulls together the Schedule 8 delays and cancellations data. So that bar chart with all of the different colors, that tool provides that information so that you can identify the weather impacts in a particular location in the country. And also there's currently a Buildings and Architecture Climate Action Design Guide, which provides some kind of principles for climate resilient design. And DFT is in the process of developing a climate change adaptation handbook, which will be a web-based store for basically any kind of adaptation action or any kind of resilience action. So you can say, I'm a project developer working on a signaling project looking at impacts from heat, and it'll come up with, these are the risks from heat, and here are some ways that you can manage them, you know, like putting ventilation into a signaling box, painting it white, putting it in the shade, you know, these kinds of ideas, but using examples from all over the world in this handbook, so that it just provides that useful kind of jumping off point when it comes to thinking about what adaptation measures we may want to be implementing on the railway. So just in terms of using the guidance notes, and I'll just run through this very quickly, but the impact assessment process is basically starting with identify and quantify the current weather risks in a particular location, then look at future risks and quantifying those future risks, and doing that using the climate projections guidance note. And then the guidance note also goes through, you know, advice on how to use the climate projections. Now, you know, many of you may be familiar with how to do this, which is great, but we've produced these documents to support people within Network Rail and elsewhere that may not be familiar with this process, and it just helps, it helps go through it. So it's just a suggestion, it's not a requirement. Once you've done the quantification of future weather risks, then it's looking at the design options, and it's analyzing the kind of cost benefit of those different design options, and looking at how they can be integrated within the options for the program as a whole, and how can we be building resilience into the program. Do we need to move something to take it out of a floodplain? Do we need to build a viaduct rather than a bridge or a culvert in order to manage future flood risk? How can we build that into the design now so that we're not retrofitting something and spending a lot of money in the future? And the kind of output of this process goes into a report, and then that report can go through a kind of refine and update process until eventually it is the project is constructed and then maintained into the future. So that's the guidance that we have. So just to give you an example of kind of adaptation in real life. So this is the Conwy Valley in Wales, and this area floods a lot. It's got a link into tidal characteristics, but it also kind of captures a lot of rainfall when it rains. This is, I think this is about 2015, maybe 2019. What you can see, particularly this bottom picture, shows you how high the water level is, the one on the left compared to the one on the right. So the whole railway just gets inundated with water. And what happens is, so the water rises. The problem is when the water recedes, and it just takes the railway away with it. And now this happened in 2015, and in 2015, the railway was rebuilt like for like, so rebuilt as it was. And then in the same area, it washed away again in 2019, and in different areas in 2020. And what we decided in 2019 was that rather than rebuild the railway like for like, we will actually start putting resilience into the system to prevent these kind of massive washouts. And that's why in 2020, the areas where we'd put this resilience in didn't wash away, proving their success. And it was other areas that did. Because it takes us months to fix these types of events. So what we did in terms of the resilience was put rock armor along the side of the track. So the issue basically is it floods, the water comes over the railway line, and then it rushes to get back into the river. And that's when it takes away the track. So by putting the rock armor in there, it just pulls the water and slows the flow. And so it doesn't wash away quite so quickly. We also increased the size of some of the culverts underneath the railway line in certain areas, which actually helped reduce the flood levels to the houses behind in that particular area. So this does not prevent the flooding from occurring. So the railway line still floods, and it's still closed for a day or so when it floods. But the point is that it doesn't wash away, and it's not closed for months. We just have small little washouts, little bits of ballast coming out. And so these are much easier to fix, much quicker to fix. And so we're back up and running, within a day or two rather than months later. Now, we've had 4 big flood events since kind of 2020, which would have resulted in these dangling railway line type of impacts. But we've only seen this small level of impact. But what it means is that we've spent about 60% extra on the repair of the railway in order to build this resilience in. But because of these 4 flood events, which cost around about £2 million each, we've actually already made our money back by the fact that we haven't had to fix the railway each time it would have flooded. And so it really demonstrates the value of being proactive and about building resilience into the system from the start, because we are avoiding loss in the future. And one of the other benefits of this is that actually this particular line has seen, it used to be out so often because of weather impacts that passengers just didn't trust that it would be running, and so didn't use it. But now it's more resilient, and so actually there's been even post-COVID, there's been an increase. Sorry, even during COVID, there was an increase in the number of passengers using the railway line because they trusted that it would get them where they needed to be. So that is just an example of one of the things that we're doing, and we're doing this in a lot of different areas. And there's a lot more that we're doing, which is set out in the regional adaptation plans, which, as I said, will be published next month. So I'll leave it there. Very happy to answer any questions anyone might have. Thank you.
Thank you so much, Lisa. That was a really useful insight into Network Rail's process around thinking about climate adaptation, resilience, and some of these extreme weather-related impacts. As Lisa said, please do put your questions for her in the chat, or you can raise your hand as well if you have a question to ask. Just to kick things off, I was really interested to see the kind of flow chart that was worked through in terms of that kind of climate change and weather-related impact. I wonder if you could comment a little bit on how receptive some of these kind of different stakeholders involved and particularly the kind of design and construction teams have been to these types of processes.
I think there's a recognition that it's important to do this analysis. I can say that I know that it is difficult to take science and turn it into engineer speak, and that's what we're trying to do, and we haven't necessarily cracked it. So there are improvements that can be made to the guidance. But generally, I think that it is helping us look at risk and start thinking about it in project development. And when I say helping us, I mean the consultants and the people supporting us do the work on the projects around the country. It's helping have that conversation about climate change impacts and start to build resilience into the system. One of the problems we face at the moment is from a cost and funding perspective, and there's more work to be done to really help people see the value of investing in resilience now, because it tends to be one of those things that's value engineered out. And we need to try and stop that happening so that we are building resilience in every project that we do.
Great, thank you. And you had that kind of graphic, which you mentioned was in the report around the interdependencies that you explored. I wonder if you could just talk a little bit more about the process of kind of putting something like that together and who you had to engage with to get that going, because obviously it's a very complex area, but very important one.
Genuinely, that graphic was a few people in a room just making stuff up for a day. So it's just a kind of, well, we know that power sector impacts us. If there's no power, we can't run trains. If there's no trains, doctors can't get to the hospitals, and the hospitals might then have a problem treating people with heat impacts, that kind of thought process. The work that we're doing now on the update for ARP4 is, that is a wider stakeholder group. So we're using, it is surface transport. It's primarily linked to the different surface transport groups linked together. We're all involved in working groups, and we're doing much more research in terms of reviewing other organization and other infrastructure managers' adaptation reports to get information about their risks and building that in and developing a methodology for doing the risk scoring. So yeah, a lot more effort is going into that. But that initial high level piece is genuinely just a brainstorm of where do we think those links come together. There's also work that the Committee on Climate Change has done for the third climate risk assessment, which is looking at interacting risks and interdependent risks, and that's also useful information.
That's great. Thanks, Lisa. I think, exploring those links between different areas and that kind of systems view is so important with these kinds of topics. I'm just going to check if there's anyone with their hand up in the room or if there are any questions coming through. Doesn't look like there is at this point, but please do feel free to put them in the chat if they kind of come up later on. A massive thank you to you, Lisa. That was really, really insightful and really useful to get that kind of insight into how Network Rail are handling this topic. So thank you very much for that. In the interest of time, I'm going to move on to the second part of this event, which is the workshop session, which will be led by Eleni Antoniadis. Eleni is Vice President at the IES, where she founded and continues to play a leading role in the EIA community. She is also a retired Vice Chair of the IES and has been a board member since 2016, helping to shape the organisation's strategy. Eleni is a project environmental and sustainability lead with more than 20 years' experience in leading the environmental impact assessment and environmental management during the design and construction of infrastructure projects. In recent years, her focus has been on the delivery of aviation and infrastructure projects in challenging environments, specialising in Antarctica. Eleni, over to you. Thanks so much.
Hi, everybody, and thank you for joining. Lisa, I wanted to say thank you very much for providing this update. I haven't worked on network rail projects for a while, but I may be working on some in the near future. So it's always really useful to have the latest guidance and stay up to date with the rail sector. So I just thought we would move on to the second part, which is our workshop. Let me just make a start on it. So our workshop is going to be related to Lisa's talk, and it's going to talk about how we look at climate resilience as part of the EIA process. Ethne gave an introduction to me. At the moment, I'm Vice President at the IS, and I established the EIA Community back in 2020. And the rest of the time I work as a project environmental lead on aviation and infrastructure projects. So a little bit about our EIA community. We launched in 2020. Today's actually our 7th debate that we've had since launching. These are organized with Ethne mainly and myself. We started off looking at competency in EIA and net zero and the challenge of integrating net zero with EIA. Then we looked at the EIA for better design and bridging the gap between construction and EIA. We collaborated with the ICE, the Institute of Civil Engineers, on design as part of the EIA. And last year we started this series of extreme weather events and EIA. And we had a session in July with the Met Office where they spoke about their projections, and we had a workshop. We have Lisa with us today from Network Rail, and we have some more webinars coming up, which Ethne will tell you a bit more about. If you'd like to read more about the community, there's a link. I think Ethne's put it in the chat also, where you can find out about our different webinars we've had so far and all our work with the EIA working group and our papers. So we do actually consider climate change and future scenarios in EIA. How do we do this at the moment? Well, there's a requirement under the Schedule 4 of the EIA regulations to consider the impact of a project on the climate, and also look at the vulnerability of the project to climate change. There's a number of resources that are used depending on the project sector. We had a really good summary just now on the resources that you would use for a rail project. You may look at, if you're working in the UK, the Met Office climate change predictions. These look at things like temperature, precipitation, sea level rise, and carry out climate resilience risk assessment, flood risk assessment, or other specialist studies that fit into the EIA. Or you might look at the IPCC climate change scenarios. And again, these are focused on mostly physical parameters. At the same time, we need to carry out an assessment of the operational impacts of buildings and infrastructure. So under Schedule 4 of the EIA regulations, we're required to describe the main characteristics of the operational phase of a development, such as energy demand, energy use, nature, materials, and so on. But how do we actually define the operational phase of a project? Well, infrastructure projects have a specified design life, and this can really vary. For the design of a building, it varies depending on the type of structure, the type of building. It could be up to 50 years, but as we know, some buildings might, like our Victorian buildings, might stay in place for beyond the intended design life. When we're looking at the design of civil infrastructure, the design life of it, this is even longer, and it does vary depending on the infrastructure and what the purpose of the project is. For a bridge project, this is usually around 100 years, but for major infrastructure projects, they may be designed with a design life of up to 120 years. But some infrastructure would stay in place beyond its design life. For example, tunnels, like all the tunnels we have below London, they would stay in place beyond their design life because it's very unlikely that they would be removed or anything. So the environmental assessment of the operational phase usually looks at an opening year of a project, for example, for landscape, air quality, and noise impacts. However, what about the impacts throughout the operational life of a project and towards the end of the operational life? What about the impacts for the duration of the design life? So if we take the example of a bridge project opening today, this bridge would still be around in 100 years in the year 2124. So do EIAs currently assess the impacts beyond the opening year? And what will our rural and urban areas actually look like in 100 years' time? This is going to be the focus of our workshop, and we're going to break up into groups and have around a 20-minute discussion around that subject, and then we'll reconvene and discuss what we thought. So what I'd like for everyone to do is to think like without your EIA hat on and have a look at different scenarios for the year 2021. And we'll have a look at pessimistic and optimistic scenarios. So for the purposes of this workshop, it will be quite binary. And I've chosen 6 topics for these scenarios. And these are climate change, air quality, biodiversity, the built environment, transport, and population. So I'd like you all to have a look at these scenarios, and you're going to have suggestions about what pessimistic and optimistic looks like. And in your group, discuss what you think you are within these 2 different scenarios. And then when we reconvene, we'll reflect on when we're carrying out EIAs, which year do you actually envision when you're assessing the operational impacts and designing for climate resilience? What does it actually look like in the year 21-24? And then we'll ask the question, do EIAs currently take the future into account adequately? And do they consider the full design life of a project? So the topics I have are climate change, air quality, biodiversity, built environment, transport, and population. So when we break up into groups, I'll be taking one group and Ethne will be taking the other group, and we'll run through these various scenarios and have a discussion around whether we think we are a pessimist or an optimist. And we can reconvene in around 20 minutes. So that's 1 o'clock, and feedback into the room. And then we'll answer the question on whether we think EIAs are actually assessing the full design life of a project. So Ethne, do you want to take us out into the different groups?
Great, thanks, Eleni. Yep, I'll open the rooms now. Thank you.